Sliding contact bearings. Tribology is the combination of friction, lubrication, and wear. In Greek, tribos means rubbing, that is friction. Friction causes wear, and to remove the wear, we need lubrication. The function of bearing, it is a machine element that supports another moving machine element, which is journal or shaft, which carries the load. The basic modes of lubrication or regimes of lubrication or types of lubrication are thin film lubrication, which is boundary lubrication. Thick film lubrication, there are two types, hydrodynamic and hydrostatic lubrication, and elasto-hydrodynamic lubrication. The different types of bearings, the first bearing is zero film bearing, which does not have any lubricating oil film in between the journal and the bearing. So it is called a zero film bearing. Thin film lubrication is the condition of lubrication where lubricant film is relatively thin. It is very, very thin. So there is a partial metal to metal contact. You can see in the diagram where A is shown. So there is partial metal to metal contact. Now, when does a thin film lubrication occur? When there is excessive load W, you can see in the diagram, or there is insufficient area of oil supply, or there is very low speed. Well, there are certain fatty acids that contain polar molecules, you can see in the diagram. So molecules in which there is a permanent separation of positive and negative charges. So this is the property of the lubricant. It will try to avoid the metal to metal contact. The cluster of polar molecules cohering to one another and adhering to the surface. This forms a compact film preventing the metal to metal contact in region B. You can see. So this is how the boundary lubrication takes place. This is partial lubrication, as at A metal to metal contact takes place, but at B we try to prevent the metal to metal contact. The boundary lubrication or thin film lubrication is also referred to as mixed lubrication. Thick film lubrication is the condition where two surfaces of bearing which are in relative motion, they are completely separated by a film or fluid. You can see in the diagram. Now this is the diagram of hydrodynamic lubrication. You can see diagram A shows when the journal or the shaft is at rest. The diagram B shows journal when it will start rotating. It is rotating in the clockwise direction, you can see that. And the diagram C, we will try to understand when the journal is at full speed. Now what happens initially, the journal is at rest, but when the journal starts rotating, the initial metal to metal contact will take place and there is no lubricant in between the journal and bearing, you can see that. But slightly when the journal starts rotating, a little amount of lubricant is introduced between the journal and the bearing. And in the diagram C, you can see when the journal is at full speed, the oil film lubrication is being introduced between the journal and the bearing. So the lubricant is introduced in between the journal and bearing purely due to the motion of the journal. So that's why these lubrication or these types of bearings are called as the hydrodynamic bearings. So the system of lubrication in which the load supporting fluid film is created by shape and relative motion of the sliding surfaces. It is called as hydrodynamic lubrication. Like I said, initially the shaft or journal is at rest. The surfaces of journal and bearing touch during the rest. As the journal starts to rotate, it climbs the surface, you can see in the diagram B. As the speed is further increased, it forces fluid in the wedge-shaped zone. Now, here we are not going to use any external accessory like pump to introduce the lubrication between the journal and the bearing. The pressure is created within the system due to the rotation of the shaft. Hence, the hydrodynamic bearings are called as the self-acting bearings. If we talk about the difference between the thick film lubrication and thin film lubrication, the partial metal to metal contact is going to occur between the thin film lubrication, while in thick film lubrication they are completely separated by a film of the fluid. Due to partial metal to metal contact, the surface finish is going to be affected and it is going to affect the performance of the bearing, but there is no such performance of bearing affected in thick film lubrication. Now, the lubrication film is very thin, hence friction and wear is going to occur and less effect of viscosity of lubricant is going to be seen. But here the viscosity of lubricant will be proper, the lubricant is present, and hence the performance of bearing is going to rise. The example of thin film lubrication is the boundary lubrication, while that of a thick film lubrication is hydrodynamic lubrication and hydrostatic lubrication. Now, what is journal and what is shaft? The portion of the shaft which is inside the bearing is called journal. When it is outside the bearing, it is called shaft. The journal bearing, the sliding contact bearing which works on hydrodynamic lubrication and which has load in radial direction. You can see in the diagram the load is applied in the radial direction. So load acts perpendicular to the direction of motion, then such bearing is called as the journal bearing. Now, journal bearings also, there are two types: full journal bearing and partial journal bearing. You can Now in that also there is clearance bearings and fitted journal bearings. Clearance bearings, the radius of journal is less than the radius of the bearing. You can see in the diagram. But fitted journal bearings, you can see the radius of journal and bearing are equal. So fitted journal bearing must be partial bearing, otherwise it is not going to be possible, and the journal must run eccentric with the respect to the bearing in order. So you can see the center to center distance, there is some eccentricity which is shown in the diagram. It is to provide the space for the lubricating oil. The two types of thrust bearings are shown. Now thrust bearings, you can see there is a footstep bearing. So the end of the shaft is in contact with the bearing surface. And collar bearings, you can see the collar is integral with the shaft. The hydrostatic bearing, you can see the pump is going to supply the lubricant. Elasto-hydrodynamic lubrication. Basically in elasto-hydrodynamic lubrication, you can see that the two rollers are in contact and having rolling motion. So the small contact area is there. This creates high contact pressure. As the oil enters the contact zone between the two rollers, the oil pressure rises sharply. This high pressure in turn increases the oil's viscosity and load holding ability. So the load will slightly deform. It will flatten the metal of the rolling elements and race in the contact zone. Once the contact zone is passed, the metal elastically returns to its normal form as the rotation continues.